Okay, so today we will cover the topic of software performance engineering. First, why we need software performance engineering. So in practice, especially in the production environment of large-scale software systems, the software system failures are often due to performance issues rather than function bugs. It is not because of a web page cannot display something correctly. It is usually because this website cannot handle a large number of users accessing the website at the same time. So talking about a performance, usually we talk about something like loading time, a CPU usage, memory usage, and I/O, such as read, write, and network usage. Okay, let's give an example. Like for Amazon Web Service, a page load slowdown of only 1 second could cost 1.6 billion. That's a lot of money for just 1 second of delay. So, so here we talk about 1 second. That is the time to load a page. Usually we call it a response time. Okay. Another example, Service book, Service Pro tablet. So at its initial time in the market, so there is a short battery life problem. Actually, this problem was due to a software performance bug. It's not a function bug; it's a performance bug that caused the short battery life of this notebook. Okay. So today we will cover these topics. First one is what is software performance engineering, or we call it SPE. The second part is performance testing. So how we test the performance of a system. The third one is profiling. So how we understand the distribution of the performance of a software system. For example, which part consumes most of the CPU. So there are some references. The first one is actually a website. This website there's a collection of knowledge related to software performance engineering. That's very interesting. And we have another 2 references. Actually, there are 2 books related to software performance engineering. So today we don't have the chapters from our main textbooks. So it's not a problem. So you can first focus on the class. Also, if you can check the website. If you want to know more, you can check the 2 books. Okay. First, what is software performance engineering? Before that, we want to understand what is software performance. According to the ISO IEC 25010 standard, they define the quality factor called performance efficiency. You can check the definition of performance efficiency in this standard, or you can check it in the book or textbook of Laporte 2017. Okay, according to this definition, performance efficiency is the performance relative to the amount of resources used under stated conditions. Resources such as CPU, memory, network, right? Or time, right? Like how much CPU time it is used. Okay, so within this quality factor, so we have 3 sub-factors. The first one, time behavior. It is a degree to which the response and processing times and the throughput rates of a production or system when performance functions meet its requirements. So we talk about response time, processing time, throughput rates, right? These are related to the time behavior. This is the first sub-factor. The second sub-factor is resource utilization. is the degree to which amount and types of resources used by a product or system when performing its functions, right? For example, when we run a software system, we want to know that the CPU usage is under, for example, 80%. The memory usage is under like 90%. These are about the resource utilization, okay? Third one is capacity. It is about the degree to which the maximum limits of a product or system parameter requirements. For example, we run our OpenMR system on several nodes or several containers. We want to ensure that under such hardware constraints, our system can handle 100 users using the system at the same time. That is capacity. Okay, so this is about the performance efficiency and three sub-factors. Okay, so what is software performance actually? Okay, software performance measures the efficiency of the software system against the constraints of time and resource allocation we just mentioned. So we also mentioned there are several indicators to capture and evaluate performance. First one, like response time, right? Second one, like a processing rate or throughput. What is throughput or processing rate? It is the total completions per unit time. For example, Amazon Web Service. Another example, Google search can handle, like for example, 100 million search per second, or 100 million transactions per second. That is a throughput or processing rate. Okay. A third one is the utilization. It's about the ratio of busy time to total time, right? So our system is the CPU of our system is busy at, for example, 80% of the time, right? That's utilization. There are other indicators as well. So when we talk about performance, we can talk about the performance of the entire system or part of the system. For example, you can talk about the performance of the entire OpenMR system or just one module of the OpenMR system, okay? So here we understand what is software performance. Then, so what is software performance engineering? Software performance engineering is a set of tasks or activities that need to be performed across the entire software development lifecycle. The goal is to meet the documented and non-functional requirements. Such non-functional requirements broadly include performance, scalability, availability, reliability, these things. And in a smaller scope, we talk about performance only. Okay, so why performance engineering also care about scalability, availability, reliability? Because only when you have a large number of users using the system at the same time, you may measure some quality goals related to scalability, availability, reliability, right? For example, you want to understand whether your system can be reliable when thousands of people are using it at the same time, right? So this is software performance engineering. So what are the components of software performance engineering? Or what are the steps in software performance engineering, right? So when we talk about software performance engineering steps, so we relate it to the software development lifecycle. In software development lifecycle, the first step is about functional requirements gathering. So we want to get the functional specifications. For example, this system should be able to handle this feature. That's functional requirements. And for performance engineering lifecycle, we have non-functional requirements gathering. So we would gather such non-functional requirements such as the system should handle the user request within 3 seconds, right? The system should be able to handle 100 million users at the same time. That's non-functional requirement, okay? The next step is architecture and design. You want to have an architecture of your whole system. You divide your whole system into smaller components, and design is a lower level, more detailed design of your system, right? You design the structure for each component of your entire system. And for performance engineering, at this step, we need to consider performance. We need to design for high performance. For example, you have different architecture styles. Maybe one style is not good for performance. Another style is better for performance. You want to opt to the second architecture style because it's better for performance, okay? The third step is implementation. You want to transfer your architecture and design into source code. That's implementation. In this stage, what is the things related to performance engineering? We need to run unit tests. Actually, we need to run unit performance tests. We need to test the performance of each individual unit of the source code. Okay, based on this test result, we want to optimize our code to have better performance. For example, you have a sorting algorithm implemented. So you want to test the speed of the sorting algorithm or the memory usage of this sorting algorithm. And then based on this test result, you can optimize your sorting algorithm to have a more efficient code, right? Okay, then the next step is system test and user acceptance test during the software development lifecycle. So what we do for performance engineering, we have performance tests. Performance tests, usually you will consider a large number of users using the system at the same time. So usually we call it a load test, or load test is the major part of performance test. Okay. Lastly, after we test our system, we deploy our system into the production environment. And for performance engineering, we need to monitor the performance of our system. And at the same time, we need to adjust the capacity of our system. For example, there are more users, then we need to add more hardware resources to handle the increasing users, okay? So this is the life cycle of software development and the situation of performance engineering within the life cycle, okay? Then I'll talk about each steps. First step are functional requirements gathering in the software development lifecycle and the non-functional requirements gathering in the performance engineering lifecycle. So, okay. How to gather these non-functional requirements? Firstly, we need to review business requirements and documentation. From there, we get the non-functional requirements, right? Business requirements and documentation, usually high-level requirements. We need to derive lower-level non-functional requirements from such documents and requirements, okay? And also, if we already have a current version, we need to review the performance metric of the current version. So in the next version, we can understand how much, so which performance metrics we need to maintain and which performance metrics we need to improve, okay? Then we derive our non-functional requirements. Also, we need to identify the tools, resources, and infrastructures for verifying the non-functional requirements, okay? And we also need to confirm the consistency between the non-functional requirements, because usually the non-functional requirements are mutually conflicting. For example, capacity and speed, right? When you have a higher capacity, your speed will maybe slower, right? So when you handle just one user, you are very fast. But when you handle 100 million user, your system might be very slow. So we need to have a balance between these non-functional requirements. Okay. The second step is architectural design. In that step, we need to consider performance and design for high performance. Okay. So what we do, right? First, we evaluate the alternative design or alternative architectures and pick the one that is good for performance, right? And we also need to determine the capacity of the required infrastructure. For example, after design and architecture, we have a understanding of how many nodes, how many CPUs, how many computing nodes, how much memory we need to have, right? So we need to determine the capacity, and then we need to determine how many users we can handle. And in that step, we also need to define the performance targets for developers. For each individual developer, so for each individual team, we need to give some target for them. For example, if a developer is developing a sorting algorithm, we need to give them a target. So your sorting algorithm should be able to handle like how many users within a short time, right? That's architecture and design. So next step is implementation. We run unit performance tests and code optimization, right? So during development, we run unit tests, and we also need to run unit performance tests, right? For example, we need to measure the duration of our function call. That is unit performance testing, okay? And we need to install and configure performance monitoring tools for the software and its infrastructure. During the implementation, for example, we need to instrument some logging statements in the system. This logging statement may be used to monitor the performance of the system. Okay. So here, I just give a high level of the life cycle of performance engineering. Right? Okay, the next step is a performance test. So we will cover the details of performance test later. Here we have a high level. What is performance test? So we use a performance test to simulate workload model. For example, the Amazon Web Service handles 100 million users at the same time. So in our performance testing, we need to simulate this 100,000 users using Amazon Web Service at the same time. That is the first one. And we need to run this test to collect data to validate the non-functional requirements, right? And also we use, in this step, we identify the bottlenecks in the system. For example, database is the slowest part. We may need to improve the database, okay? And we also can use this one to validate the impact of code and configuration changes. For example, this version is working fine. The next version, you change something and it becomes slower. So we need to identify such cases. Usually we call such cases as performance regressions. Performance of this version is worse than performance of the last version. Okay, we need to detect such scenarios. So the developers can change their source code to fix the performance issues as soon as possible. Okay. So here we just give a brief definition of what is performance regression. We have an old version of the software system. We have a new version of a software system. Old version was developed, for example, 1 month ago. A new version is just developed yesterday. Okay, so we compare the performance of both versions, and we have a conclusion about whether the new version have a worse performance than old version. If the performance is worse, then there is a performance regression. Okay. For example, this is a documentation from Mozilla. This is about how Mozilla takes performance regression seriously. Here, what is Mozilla's performance regression policy? Let's make it bigger, right? So it says we cannot allow performance regressions to go unnoticed or unsolved during our development cycles. So during the development cycles, we will identify changes that lead to a worse performance. You need to fix it as soon as possible. That is the policy of Mozilla, okay? Here I just give an example. So last step is to deploy our software system into production. And for performance engineering, we need to monitor the performance of a system, and adjust the capacity of the system. Okay. So we need to perform performance monitoring to continuously assess software performance. And also we need to identify when the system is reaching its capacity. For example, we identify that the system cannot handle more users a few days later. So we need to adjust the capacity. So the second step is to do capacity management, right? And also during this monitoring stage, we can collect data from the production environment. We collect data about how users use our system. So such usage data can support the development of the next version. Okay, that's the overview of the steps of software performance engineering within the software development lifecycle. Okay. So why we have software performance engineer, right? So there's some advantages or benefits. First one, it defines a clear set of non-functional requirements during the functional specification stage. Okay. Second one is, because we do performance engineering at each stage of the software development life cycle, so we can find performance issues as soon as possible and prevent late and costly changes in the future, right? So we talk about the maintenance before, right? The earlier you find the issues, the lower the cost for fixing those issues, right? Also, in a production environment, because we do performance monitoring, so we can maintain a reasonable system performance. And when we identify the performance is not good, we need more capacity, we can adjust our capacity, right? To have more hardware, for example. Yeah, and also if we identify problems earlier, so we can avoid the constant problem solving, right? And the last one, because we can deliver a software system with good performance. And for example, our customers can use our system very efficiently. They can load their page very quickly. So the customer will receive the full value of our system, right? So these are some benefits of software performance engineering. However, there are some challenges. The first one is because we need to improve our time to market, and there are budget constraints. So we need to deliver our system into the market as soon as possible. And we don't have a lot of resources to conduct performance testing, because performance testing is very costly. Usually, run performance testing, you need to simulate a lot of users accessing the system at the same time. So you need a lot of hardware to simulate such large number of users. So this is the first challenge. Second challenge, so usually there's a knowledge gap between developers and quality experts. The developers, they may just they want to deliver their features as soon as possible, but quality experts, they want to ensure that the performance of their system is reasonable. So there's a knowledge gap. So I'll give one example, like the same using the sorting example. The developer may want to finish the sorting algorithm as soon as possible using the minimum code, but quality experts will want to have a high performing sorting algorithm. Okay. Third challenge is performance perceived by users. Only the users know which part of the performance is critical for them, right? So there's another knowledge gap between developers and users. The fourth challenge is so the recommended solution to solve these challenges is to do automation. right? We do automation for performance testing. So we reduce the time needed for performance testing. And we can involve customers. We can involve quality experts in the creation of the automated performance testing. So then we will talk about the details of performance testing later. Before that, so let's look at how we measure software performance. So we talk about software performance metrics. So when we talk about measurements, first we need to have objectives, right? So what are the objectives for the measurements of software performance? First one is we need to evaluate the compliance of the system with performance targets, right? So how fast our system should be, this performance target. Another one, we can provide input data for software performance engineering models. These models are used to analyze the performance of the system. We will talk about the performance models in the next class, okay? And another is to monitor the software performance during the software lifecycle. So we have static and dynamic measurements. Static is we don't need to run the system, right? Dynamic, so we need to run the system and measure the performance of our system at runtime. That's dynamic. And we also have internal and external measurements. For internal measurement, we don't rely on an external tool. We use the code of the system itself to do the measurements. For example, we insert logging statements in the source code to do the internal measurement. External measurement, we rely on an external tool. External tool, for example, will sample the CPU and the memory usage of the system. Right. So these are some basic concepts of measurement. So what is the measurement process usually? First, we need to understand the objective of the measurement, right? And then we need to identify data needed to answer those questions in the objectives, okay? And we need to specify the tools and techniques used for measurement. Then we need to identify experimental variables and controls. For example, how we should configure the system, how we should feed input to our system, right? And then we define our test cases. Then we run the test and we analyze the results. That's a high-level process for the measurement of software performance. Let's look at one example of software measurement, performance measurement, right? In this example, you need to develop a system that needs a sorting functionality. You have to choose between an existing solution or a newly developed solution, okay? So we need to define the plan of measurements to evaluate the two options. So how are we going to evaluate the different options, right? First, we need to have objectives. Objective is to evaluate whether to use a standard sorting algorithm or to develop a personalized algorithm. We compare which one's better, right? That's objective. What is about data connection? So we need to measure resource requirements, CPU, disk, memory for each algorithm, right? This is a data connection. And also we need to record different events, right? And we would also need to evaluate the measurement overhead on the performance of the system. Because when you monitor a system, actually you add extra overhead to the CPU and memory. You're adding something, you're adding more computing cost to the system, okay? This is about data connection. Next step, we design our experiments. We control the experimental variables. Examples of these variables include number of items in a sorting algorithm, right? A number of items used as input for a sorting algorithm. The item size, the size of each item. Whether the original sets of items are already sorted, right? Or the sorting algorithm itself. So these are the experimental variables. And then we, based on these experimental variables, we design our test cases, right? For example, in the first test case, we may have like 36 integers. And these integers are almost sorted. And we'll feed this one into the sorting, the both sorting, but to the both sorting algorithms, and we check, we run them, and we connect the data, right? The last step is to run a test, right? We need to run each test several times to have unbiased testing results, okay? So this is about the example of measurements for a sorting algorithm, right? So there are different data types we measure during the software development, during the software performance measurement. For example, we have workload data, right? So how many users are using the system at the same time, right? And what kind of usage patterns? Are they logging, or are they changing a password, or are they viewing the emails? Those workload data. And also we have data characteristics, the number of size of data, frequency of queries for data. For example, so when people are using the sorting algorithm, so what are the types of input data they have, and what are the size of the input data, right? And we have execution characteristics, including, for example, the path characteristics. For example, the number of executions for each important path. In the software system, we have different paths, and how many times one path was executed during the performance test, right? This is execution characteristics. And we have system usage characteristics, such as response time, throughput, right? And the CPU memory usage, okay? So these are the data types we may be used during a performance measurement, okay? However, when we do performance measurement, we have some bias sometimes. Then it is hard to avoid, and they are unpredictable. The first example is how come the same application today runs faster compared with yesterday? This happens sometimes, right? For example, today maybe you have your computer is more it's freer, right? You have a freer computer system. You have more computing power, so it's running faster. Second example is response time is different. Running the same code, but under different user account, response time is very different, right? This happens sometimes. Third example is why the code optimization only works on my computer, right? This is another bias. This can happen sometimes because there's some specialty on your computer. For example, your computer using a certain library, but on another computer using another library. So your code optimization may only work on one computer. So there are lots of measurement bias. So how to avoid them, or how to mitigate such bias? So we can do repeated measurement, right? We measure certain things multiple times, and we need to randomize experiment setup. We need to run our measurement, for example, from different computers, from different account. We need to make a randomization, okay? So this is about the bias of measurement. Okay, I also, here are some challenges for measurement, right? The first one is system disturbance. System, so so when we measure something, we may affect the actual performance of the system being measured, right? Because we add something to the original system. And also the timing of measurement. For example, when you measure something that is very short lasting, and when you measure it, maybe it's already finished, so you cannot do the actual measurement. That's another challenge. And the third challenge is reproducible results. Sometimes we cannot get a reproducible results because you have a different environment. The last one is workload generation. So how can we generate the workload to simulate the actual usage, right? Those are challenges. Okay, so we talk about performance measurement, also talk about software performance engineering life cycle. So I think I'll have a break, a short break here. And after this break, we will talk in detail about performance testing. Okay. Do you have any questions? Either
No.
here. Okay.
Don't.
Okay. So we will come back. Let's see what's the time. At 1:30. Okay, 5 minutes. Okay, 1:30. It's come back at 1:30. Bye bye.